Hello, good morning. Welcome to another episode of Sound Talk Show. We are going to code Wolfram language, Advent of Code 2025, Day 1, Problem 2, Take 2. So about 2 days ago, we did Day 1, Problem 2, but we ran into a bug, and this video took me 3 hours, 4 hours, and we didn't resolve it. But today, we're going to. So let's see. So let me copy. So let me just update. So if you are here, say hi. Love to see your comments. Hello, said tag in Moti. If you are watching this offline, play at 1.5 speed. Okay, 1.5 speed. Advent of code, programming, racket versus Scala scheme. Lisp. Some comments. We have discussions about programming. So hold on a second. So let me do this. Open this so that this is Sound Talk Show Day 1 Problem 2 episode 721. That was 2 days ago. And today is 723. So copy that, show in browser. Let's add to the topic box. Okay, Advent of Code 2005. So there, show in browser, go to the bottom. So you can see we added today's into the topic box. So refresh or close. Now show today's talk show. There we have it, today's. Okay, so let's begin. Okay, watch at 1.5 speed or higher, and say hi. And we're gonna start. Am I good to go? Video check, audio check. So let's see this window. Okay, we need to close this one so that you can see it. Okay. So talk show. So let's grab the code from the other day. So let me tell you what was the problem. So that one, show in browser. In fact, we can just copy that. Okay, and start code here. Wolfram language, paste the code, show in browser. So the problem is you have, you guys know the problem, right? So let's see. The problem is that you have this rotational dial, and so at any point, so there's 0 to 99 numbers around a circle, and at any point there's an index pointing to one number. So usually the number is at the top. Imagine this is a combination lock, rotational. And so the problem is, you are given a bunch of left and right rotation instructions like that. Rotate right 20 means clockwise. Rotate left 11 means counterclockwise 11 times. So given this rotational lock 0 to 99, and given a starting number, and given this bunch of instructions, rotate left and right, then you want to find out how many times each rotation passes 0, either pass 0 or end up at 0. Okay, that was a problem summary. Now, if you haven't done this, you watch previous episode or just read the Advent of Code website. Okay, so that's a summary. So the gist of the algorithm is a function which we have written here, X operation. Given the current number and given the rotation, so when you rotate left, L something, L a number, that can be considered as a minus, a negative number, right? And R is a positive number. Why? Because we are doing modular arithmetics. So can we see so let me show you this this diagram. So the numbers are arranged in a counterclockwise way. So when you rotate left, what rotate left means rotate counterclockwise. So in effect, it decreases the number. When you rotate right, in effect, it increases the number. Okay, so the heart of the operation is this function. So this function, here's a documentation. Here's a documentation operation. Current number rotate count returns the least CD rotate n can be negative. Okay, returns the least CD. C is the number of times it passed 0, and D is the new index number, meaning that after the rotation, what is the number at the top? Okay, but this function has a bug, which took us 4 hours the other day and still not resolved. So we're gonna resolve it today. So everything is good. Okay, so let's just pay attention. Okay, so you just so what we did is quotient. We call the function quotient remainder. So what this function do is, for example, let's say 10. Let's say 10 divided by 3. It will return the quotient and it will return the remainder. So if we evaluate this, it will return 3, 1. So meanwhile, let's start. So you can see here's the result. And I'm using Wolfram mode that allows me to code Wolfram language in Emacs. So if you don't know, watch my previous video. I have introduction on the Wolfram language on where to download for free and Wolfram mode. Okay, let's start Wolfram language meanwhile. So far so good. So far so good. Any questions you have on Wolfram language, you can ask me. Okay, so 3, Shift Enter to evaluate it, and let's increase the font size. Okay, so quotient remainder, so you can also run it here. Run it. Okay, now if you say 4, 10 divided by 4, it will return 2 and 2, 2, because quotient is 2, remainder is 2. 10 divided by 5, let's do it again. Control L to copy the previous input. Let's say 5, Shift Enter to evaluate 2, 0. So you see, so this is the heart of the algorithm. This should tell us when you rotate left or right, how many times it passed 0 and or ends up at 0. But there's a bug. So it should be something more than this. Okay, so let me think about this. So we need to so it is this bug that we spent like 3 hours and didn't figure out. Okay, nobody is here, so let me just think about this. So you want to know the number of times it passed 0 whenever you rotate. Okay, so but first of all, if you do this quotient remainder, it will give you a number, and this can also be negative. For example, -3. Wait, 10 -3 becomes -4. Okay, so Oh, that's... Oh, okay. I think that's the problem. We would like wait. Let's think about this. 10 negative 3. Why is it returned 4? Why is it negative 4? Okay, I think... Oh, right. So wait, you got it wrong. So this is out, right? So yeah, so 10 divided by negative 3. So that would be 10 divided by a negative number is equals to 10 divided by a number. Then the whole thing multiplied by a negative sign. So wait, so I don't get this because I think this should be negative 3, 1. So let's look up the documentation. Shit, we got into another problem, another issue about edge cases of the design of the quotient remainder function. To think about this issue is gonna take half an hour. So quotient remainder is also known as a ratio and quantity left over from division n by n. Ratio and quantity, integer mathematical functions suitable for both symbolic and numerical manipulation. Okay, gives a list of quotient and remainder for division. So in Wolfram language, because it's symbolic, so what you can do is actually use symbolic answers. I mean, anyway, never mind. So here the quotient remainder is all positive numbers. It's all using positive numbers in this Wolfram language example. But in our case, maybe it's just because so this is troubling. So this part is troubling. Why is it return negative 4 too? I mean negative 4. Yeah, this part is troubling. So wait, shift enter. Okay, so if it's negative, okay, what if it's negative 10, 5 to 0, 10, 5 to 0, 10, negative 5, negative 2, 0, that's expected. Negative 10, negative 5 to 0, that's expected. Now, now what about negative 10, 5? That should be negative 2, 0. Okay, that's all expected. But now this 10 negative 3 is not expected. let's see, 10, 3 is 3, 1. That's correct because 3 times 3 is 9. There's one remainder, okay? Now 10 negative 3 should give you negative 3, 1. But it's not. This is puzzling to me. Oh God, we went into this math issue. Quotient remainder, does it talk about negative number? Let's read carefully. Gives a list of the quotient and remainder from division n by n. Okay, so if you have this 3, so this also works out. You see, over here it's 3 times 3 is 9 plus 1 is 10. Now over here, negative 3 times negative 4 is 12 positive. Positive 12 minus 2 is 10. That's also work out. But if you have negative 3, if the result is negative 3, 1, that should also work out. You see, if the result is negative 3, do you guys see what I'm saying? So if the result is negative 3, 1, you see, negative 3 times negative 3 is 9 positive. And 9 plus 1 is 10. So this should also be the result. But why is it returning that instead? So we are digressing into this design of a mathematical function issue. And to dive into this issue could be 1 hour or more. So here are the examples. One thing annoying about Wolfram language documentation is that they use images, so you can really enlarge it. Okay, anyway. So plot the sequence scope. Quotient remainder works over integers. That's right. Rational numbers, inexact real numbers. Okay, that also works. Exact numbers. Okay, you can also use symbolic numbers such as pi or exponential Euler number. You can also use complex numbers. It also works. Compute for large integers. Okay, huge integers also works. Quotient remainder threads elements over lists. Okay, so you have a bunch of lists, you just apply to the bunch of lists. Now, it didn't mention negative basic applications. Plot a quotient of a number of division by 5. Plot the remainder of a number division by 5. Plot the quotient of two integers. Number theory, okay? Then you got number theory. Use floor to compute the quotient for integers. Okay. Demonstrate how division works. Count the number of positive integers less than 1000 divisible by 2 or 3 but not divisible by 6. Okay, some examples, but you did not mention negative numbers. What if you have the input is negative? Okay. It did not mention negative numbers. Okay, I think this is a flaw of the documentation. Can you guys see what I'm seeing? You see the quotient remainder 10 over 3 returns 3, 1, but 10 over 10 and negative 3, it returns negative 4 and negative 2. but I would expect it to return -3 and 1. That is the problem. And the documentation did not talk about what if your arguments are negative. Yeah, it doesn't say. Interesting. Is it interesting? Because this, let's just write it out, okay? Okay, that's interesting. Okay, now let's just copy that. Okay, let's create a new. Okay, today's talk show, that's a question. Let's double check our logic. That's a very interesting question, and the documentation does not talk about it. Did we miss anything? Okay, so let's move on. So, okay, keep that in mind. Now let's move on to our problem. Okay, so the problem, we want to know the number of times it passes 0. So you can just take the absolute. So let's just make sure when we call quotient remainder, we always make it positive number, so we don't get into this unpredictable issue. Okay, I'm still a bit sick from cold. Check video check. Am I going well? Okay, so okay, so now so you got this rotational. Let me just think. Quotient remainder, current number, rotate, and rotate can be negative, okay? And when you do that, you see, you want it to, you want to make sure this part is always positive. Now, in this case, what if you say, you see, that also returns -4. You know, I'm expecting 3, 1, but it returns 4, 2. It's not desired. So you just want to make sure when you call this function, what if you call the quotient okay, there is a related function which is just a quotient. Maybe over there they will explain. Let's see, quotient gives an integer quotient m and n, use an offset. Quotient is also known as ratio or fraction. Okay, integer mathematical function gives the greatest integer no larger than, oh, okay, there it is. Quotient mn gives the greatest integer no larger than m over n. That is why it returns -4 instead of 3 when you have a negative input. That's why. So, yeah. So Wolfram, the quotient remainder is just to be consistent with this quotient thing. Now, we can look up Wikipedia for curiosity's sake to see how other programming languages or how traditional mathematics deal with this issue when you do a quotient and one of the number is negative. Because, you know, when one of the number is negative, you have this issue. You have to decide so that's like a separate research problem. Okay, let's write this down, shall we? Copy that. Greatest integer no larger than m over n. So if it's 10 over 3, then that's 3.33 something, okay? And in this case, it's negative 3.33. So it says gives the greatest integer no larger than that. So you have a choice of -3.1 or -4.2. So you don't want to be larger than -3.3. So -3.3, then the larger number is 3, the smaller number is -4. That is why it returns -4. I feel like this is our choice. So, because, you know, so, but anyway, that's how it is. Okay, let's document it. Let's just copy that. So, when you have 10, 3, let's see, Okay, this is interesting. The value of m over n is 3.3. 3333, okay, is negative. Smaller into the greatest integer no larger than is therefore negative 4. That's the reason. Okay, that's the reason this behavior. So we explained it. Now showing browser. So you see, our problem is we run into this quotient remainder. When one of the number is negative, it returns kind of odd result. And test 10 over 3, you can see it there. It returns negative 4, negative 2. And the reason why is because it follows to be consistent with the quotient function. You see, the quotient negative 10, 3, it returns negative 4. Now, so why does the quotient make that choice? According to the documentation, it gives the greatest integer no larger than m over n. Therefore, when you do quotient 10 and 3, the value of m over n is negative 3.33, negative. So the greatest integer no larger than that is negative 4. So that is why it returns that result. And therefore, that is why quotient remainder returns, negative 4. So that is the reason. Okay, so that is like a short digression about this thing. So let me just clear that up. Okay, so okay. Okay, now we understand that part. Now let's go to work on our problem. Okay. So now when we want to call this, we want to make sure this part is not negative. Current number plus rotate n. So now rotate n can be very huge, can be a huge number. So yesterday, the day before, I think that is why, part of the reason our solution is incorrect. It's kind of tricky because of this. So now let's look at the input. Do we have the input here? No. So topic. So let's go to input. Okay, so here is a bunch of numbers we got. So if we copy that, make it new one line per number. So you want to look for huge numbers. So you can see 528. So that's like five times over. So when you when you minus that number, current number minus that number, you get the minus number. So you want to so this is bad. So let's see. So what are some of the large numbers? Okay, you got 750, 789. Okay, 3 digits basically, mostly. Okay, close it. Showing browser. Yeah, so now we know what is the problem. Okay, so what we can do is just here times 100 times a big number, let's say 999. So it becomes very big number, and it won't be positive. We don't want to. We don't want negative. Okay, so basically this part we don't want it to be negative. So that will that solve the problem? Let's run it. Select all, paste, just run it. Oh, wait a minute. You can't just add a big number there because the quotient gets huge. Oh God. Because the quotient is the number of times it rotates. Okay, so you can't just add a big number. Then okay, another way to do it is if you add a if statement. Oh God, this is getting very annoying now. Now this is gonna take another long time. Hello, Dose Bellum inexpert or Dose Bello mine expertise. Okay, we run into issues. So such a trivial problem. So how about let's just solve the problem. Number plus rotation. The rotation can be negative. So when the rotation is negative, okay, so you don't want that. So let's copy, select all, paste, run it. So this is a new function. Okay, so separate it. Okay, 0 0. Let's see. 5. What are you coding for? Advent of code. Look at the YouTube title. I want to solve this. Okay, so you want this number of times it passed 0. So when it's negative, so you could have a huge negative number. Okay, well, the easiest way is if you actually start to do like coding if expressions. Okay, check the sign, that is. So negative is minus positive. Rotate right is positive. Rotate left is negative. And rotate left is negative. And so let's just think about rotating left. So rotating left, it's a negative number. So you want, so current number rotate left. So what you can do is so that will give you absolutely quotient absolute. That will, that will avoid running into this negative input problem. Okay. So if the current number is 1, you rotate left twice, then you also pass 0. So you want to plus the distance. Yeah, very annoying. Okay, the number, the left-hand side, the first argument is always positive, so this doesn't make sense. It's just shit. This other question is bugging me about quotient. So that question is bugging me about the quotient. So for example, that like that. Okay, let me ask AI. Okay, if you ask AI this question, it will start to explain that will lead to different programming language or math convention. There it is. It start to explain. So control, magnify. In many programming languages and mathematics libraries, especially Python's math quotient, or similar function in other languages, the quotient function performs integer diversion that rounds towards negative infinity. Right, that's another way to say it. Okay, so okay, it's simply just do a floating division and rounds towards negative infinity. Kind of sloppy. You see, if math convention does this, that's because it's easy to do. Sloppiness. Is that right? Something. So if we truncate towards 0, like in C, Java, JavaScript, or simple int division in some context, we would get -3. Right. So there are two choices. Okay, so yeah, so you got two choices in this quotient thing. Now, let's ask what is the more popular? What? What is the math convention for quotient function to return for that to return negative 3 or negative 4? Okay, there is no single universal mathematical convention for how integer quotient should behave with negative numbers. Mathematicians in programming languages have historically chosen two main camps. Yeah, obviously two main camps, but which one? That is my question. What real mathematicians usually do in pure mathematics papers, when people write quotient and remainder for integers, they almost always want the remainder to be non-negative. Okay, the remainder to be non-negative. That is classic Euclidean division definition. To satisfy that, the quotient must be floored. Oh. So it truncates towards the negative infinity, which is Wolfram Mathematica behavior. Wait, both of these cases, what? So most number theory textbooks and essentially all modern abstract algebra text implicitly use floored version. Okay, so their result is negative 4. Why do they want that? Because they want the remainder to be non-negative. Now, yeah, but that still does not explain. You can also return negative 3, 1, where the remainder is non-negative, because negative 3 times negative 3 is 9. 9 plus 1 is 10. So negative 3 and 1 is also, negative 3 is also a solution. So quotient should return 3, not negative 3, not negative 4. What? However, in elementary school arithmetic in many countries and in some older programming languages, teachers and students are taught to ignore the signs, divide, and put the sign back, which effectively give truncation towards 0. This is actually more intuitive. That's what it should be. Okay, so which is the mathematical convention? Number theory, abstract algebra, -4. ISO standard for programming languages since 2010, -4. Python, Julia, Ruby, modern C++, -4. Old C, Java, JavaScript, PHP, -3. My primary school curricula, many primary school curricula, -3. Okay, so I think -3 should be the better answer. Okay, no, what the fuck? But Wolfram language return -4. So here's a question. Now cut it. Now let's put it back. Okay, let's put back the investigation into this question, because this is actually quite interesting. Okay, so copy that. We didn't solve the problem, but we into this digression about this, what quotient of a negative input should return. Okay, and it mentioned JavaScript, so I wanted to check out, to test JavaScript. So JavaScript object reference and math. So what is the quotient function? Math. We have max, min, random, sign, absolute, ceiling, floor, round, f round, trunk, power square, cube square root. Is there actually a quotient function? I don't remember. So what are you talking about? So you are saying that old C, Java, JavaScript, PHP truncation towards 0. So you are saying that, but I'm not seeing a quotient function. What? I don't think there's a quotient function in JavaScript. Okay, let me double check. Math operators. Mod, well, you can do mod, which is similar. Okay, so okay, so now 10 wait, 10 over 3 console log, what you get? 3. What? 1. What? What? Did we run into another problem? What? Why is it returning 1? Are we running into another problem? Oh, remainder. That's right. It doesn't, that's right. It gives you the remainder, but we want the quotient. but as far as I know, how to get integer quotient in JavaScript. As far as I know, there is no such function. So that's right. So either you have to manually do floor or ceiling or truncation. Okay. So in JavaScript, there is no quotient function. That means this Grok AI result claiming about JavaScript is incorrect. Okay, I verified. So now let's put it back. The Grok AI saying that JavaScript truncates towards JavaScript quotient function truncates towards 0 is incorrect, because in JavaScript there is no quotient function, no integer quotient function. Okay, so this is careful deep dive on AI answers that is incorrect. Now it got JavaScript wrong, and you might it may actually not get C or Java result correctly. So what about Python? Okay, so Python's got math quotient. Okay, so let's do Python. Let's just double check. So math, I suppose you have to import math, then the math quotient 10 3, then you have to print it, run it. Math has no attribute quotient. What is the Python quotient? What? How to do integer quotient in Python? Don't remember. So let's look up, or let's go to my Python tutorial. Number separator, floating number, binary, hexadecimal, complex number, exponential, number operators, addition, subtraction, multiplication, power, divide, integer quotient. There it is. Slash. This Grok AI is wrong again. That's stupid. Grok AI. Okay. So in Python, there is no, there's just slash. Okay. Slash. Okay. That will return 3. Okay, that's correct. Now, if you say -10, it will return -4. There it is. Not satisfactory choice of result. Okay. So we got that. So okay, so that is so now we need to show a example of a programming language where it actually returns -3. You see, there is none. Okay, we digress long enough. Double pen spinning action. That's right. So back to our question about solving this issue. So do we still need to solve it? Yes. Okay, that's Python. Okay, now let's back to coding this issue. So the quotient function, if the input is negative, then you got a issue. Python org, you see, they got the interesting. Did they have a new color of their logo? That looks like a new color of their logo. Was it python.com or python.org? Okay, let's ignore it. So what are we doing? So that's JavaScript. So we want to get the this thing. So the easiest way is you just do if statement. Okay, so the easiest way to write this function is you just like manually hard code, then you figure out some trick to make it fit into this one single function. But to start from beginning, you just manually code it. If so, you can what you can do is so first of all, you got this number. Okay, let's write block is a local variable. Okay, so we say okay, so first of all, get the overall pass. Absolute. Okay, then you do if rotate is greater than 0, less than 0. If it's less than 0, then wait, if Python best land. I don't think so. Python is the worst land. Yeah, got a very annoying problem. Rotate left and rotate right. If this almost works. It's such simple, almost works. So why is our code is so great? It actually works. It only doesn't work when the current number is 0. Right. The only reason it doesn't work is the current number 0. So because it actually does 1. Okay. So it's negative. Rotate left. And is less than is negative. I'm very I'm not concentrated, and I gotta go. This is so bad. Day 1, part 2. 6 hours on it and not done yet. But I think I gotta go. Oh God. So what are we doing? Yep. So you just need to concentrate thinking about this, or just do trial and error. So last time we found the exact bug, so it's like some +1 or -1 will work, but trying to model this correctly logically needs some more concentrated thinking, and I'm not up to it. So maybe I should stop today. But we did find an interesting thing about the quotient when the input is negative. Okay, I think that'll be it today. Okay, I gotta go. And then we'll do it. Maybe I'll just code it offline because offline that's the best. Then we got day 2 and other things to go. Actually, recently I've been looking into Julia, the programming language Julia and F#, and also Guile scheme and Racket scheme and Haskell. It turns out F# is more popular than Haskell and Guile scheme and Racket scheme combined. F# is more popular than them all. And it turns out Julia, the programming language, functional programming language, is more popular than F#. So that's a very interesting finding. So that made me want to also learn Julia because right now I'm on track to learn F#. So I've been wanting to do, with AI help, I can do problem 1 with F# or maybe Julia too. So, there's a lot coding. So anyway, so today, let's stop here. So because I'm not going anywhere. Okay, thank you guys for watching. Bye, guys. End stream. Okay, it is very embarrassing. Day 1.